Kuzampola. Welcome to Bhutan e-learning program. My name is Mohan Chetri, and today I'm going to take you through chemistry relation for key stage 5. And the topic that we are going to study today is amino acids. Now, by the end of today's lesson, you should be able to first write the structure formula of amino acids. Second, write IUPAC name of amino acids. Third, describe optical activity of amino acids. And fourth, explain the terms like zwitterion, isoelectric point, etc. Now, let's begin. First, the first question that comes in our mind is, what is amino acids? Amino acid is a special type of acid. It's special because it contains two functional groups. On one side, it contains amino group, and on the other side, it contains carboxyl group. Therefore, it's very special type of acid. It's called amino acids. So you can see here on alpha carbon. Alpha carbon is a carbon which is attached to functional group. Here the main functional group is carboxyl group. Therefore, the carbon which is attached directly to this functional group is called alpha carbon. And on this alpha carbon, amine, another functional group is attached. Therefore, it is known as amino acids. Let's look at this. Amino acids contains amino group and carboxyl group as functional group. It contains two functional groups, unlike other acid which contains only one functional group, that is carboxyl group. Now, second, alpha amino acids are the building blocks of proteins. We take lots of proteins, and all these proteins that we consume, we eat, are made up of amino acids. When all these amino acids combine together, they make proteins. Third, in alpha amino acids, amino group and carboxyl group are attached to same carbon, which is called alpha carbon. If I explain you a little bit about alpha, beta, and gamma, when we assign alpha, beta, gamma, suppose I am writing this as alpha, because this is our main functional group, and this carbon is directly attached to the functional group. Therefore, we write this one as alpha. In case if you have another CH2, and then here we have amine group here, then this will be our beta. In case if you have again one more carbon in the chain with amine group, then this carbon will be known as gamma. So alpha carbon is a carbon which is directly attached to the functional group. Beta adjacent, and gamma carbon is the one that is present on the other end. So here, when you talk about alpha amino acids, we are talking about this carbon which has alpha carbon, which is directly attached to functional group. Now, nomenclature of amino acids. As we know, whenever we name any organic compounds, there are two ways of naming them. One is common name, and other one is IUPAC name, also known as UPAC name. Now, when you write common name of amino acids are generally named as amino substituted aliphatic carboxylic acids and are designated as alpha, beta, gamma, etc., depending upon the position of amino group on the carbon chain. And when you write IUPAC name, then the name of amino acids, the position of amino group is indicated by the number of carbon atom on which it lies, taking the carbon of carboxyl group as 1. Let's practice few questions based on this one. So let's look at this first one. Now, if you look at this one, this is our functional group, so therefore this is alpha. So it is, the common name of this one is aminoacetic acid. Aminoacetic acid. What will be the IUPAC name? Now, as we have discussed, when you write the IUPAC name, we are going to give number 1 to first carbon and number 2 to second carbon. Therefore, amino group is present in second carbon, so it will be 2. How many carbons are there? 2. Therefore, 2 amino 1 ethanic acid. So let's look at this one. 2 amino ethanic acid. Again, let me explain you. Carbon of this carboxyl group is counted as 1. This carbon is 2. So amino group is present in 2 second carbon. Therefore, 2 amino, and there are 2 carbon. Therefore, ethanic acid, 2-amino-ethanoic acid. Let's look at third one, IUPAC name. Now this is alpha. Again, amino group is present in alpha position here also. Now alpha amino. Now how many carbons are there? 1, 2, 3. Propionic acid. Alpha amino propionic acid. Now what will be the IUPAC name of this compound? Now let's look at this. Now this is carbon number 1, this is carbon number 2. So 2 amino. So in carbon number 2 we have amino. How many carbons are there? 1, 2, 3. So 2-amino propionic acid. This amino acid is known as 2-amino propionic acid. Now third one, let's look at this. So this carbon which is attached directly to the functional group is known as alpha, as I have explained earlier before. Then adjacent carbon is known as beta. So you can see here, amino group is attached to beta carbon. Therefore it is known as beta amino. And since we have 1, 2, 3 carbon propionic acid, so common name is beta amino propionic acid. Now let's assume what will be its IUPAC name. Now when we write IUPAC name, we have to give number 1 to the carbon of carboxyl group. So that's number 1, number 2, number 3. So it should be 3. How many carbons are there? 3 amino, because in position 3 amino group is present. Now 1, 2, 3 propionic. So it should be 3-amino propionic acid. Hope you have guessed the right answer. Now let's look at the last question, that is 1, 2, 3, 4. So we know that this is alpha because it is directly attached to functional group. This is beta because it is alternate. Then this is gamma. So here you can see amino group is attached to gamma carbon. Therefore it is known as gamma amino 1, 2, 3, 4 butyric acid. Gamma amino butyric acid. Now please can you try to write the IUPAC name of this compound? When you write the IUPAC name, I'll just give you a hint. Please start giving number from this carbon. This carbon will be numbered 1. This will be 2, 3, 4. So please can you try? Okay. Now let me give my answer. So 1, 2, 3, 4. So 4 amino. How many carbons are there? 1, 2, 3, 4. Butyric acid. I'm sure you got right answer. So 4 amino butyric acid. So with this, I'm sure you got some idea how to name these amino acids, both using common name as well as writing the IUPAC name of these amino acids. Now, classification of amino acids. Basically, there are 2 types of amino acids. One amino acids which is known as essential amino acids, and other group of amino acids which are known as non-essential amino acids. Now what are essential amino acids and what are non-essential amino acids? Essential amino acids are those amino acids which are not synthesized in our body. It is not synthesized in our body. Therefore, we have to take it from external source. Maybe from animal proteins, or maybe from animal source, or maybe from plants. But our body cannot synthesize these proteins. Such type of amino acids are known as essential amino acids. So if I explain from here, the amino acids which human body cannot synthesize and must be supplied in the diet are called essential amino acids. Well, those which are synthesized by human body are termed as non-essential amino acids. Non-essential, you don't have to take from external source because our body can synthesize itself. So it's not necessary to take from external source. Whereas essential, since our body cannot produce this type of amino acids, we have to take it from external source, maybe from plant source or maybe from animal source. Now, the lack of amino acids in diet can cause diseases such as kwashiorkor. So it's very important to take sufficient amount of amino acids from external sources, especially those essential amino acids. Now let's look at this, optical activity of amino acids. Now, almost all amino acids are optically active because they contain asymmetric carbon atom, except glycine. Glycine is only the amino acid which is optically inactive. Now let me explain with the help of this structure. Now, if it is glycine, then what happens here? You can see glycine, both hydrogen atoms are attached to carbon. Therefore, there is a plane of symmetry. this molecule is not chiral carbon. This carbon is not chiral. This carbon is not asymmetric carbon. As you know that for a substance or organic compound to become optically active, there are two conditions. One, mirror object should be image, and its mirror object or mirror image should be non-superimposable. That's condition number one. And condition number two is it should contain asymmetric carbon atom. It should contain asymmetric carbon atom. But here, as you can see, in glycine, the carbon atom is not asymmetric. Therefore, it is the only amino acid which is optically inactive. Otherwise, this will be R, alkyl group. It can be methyl, it can be ethyl, it can be propyl, it can be butyl, it goes on. So we have about 20 amino acids. Only thing that changes in the structure is this alkyl group. Rest remains same. Therefore, all amino acids are optically active. Now, when I say all amino acids are optically active, they exist in two isomeric forms. They exist in D form and L form. D stands for dextro, rotatory, and L stands for libo-rotatory. Those amino acids which rotates the plane polarized light towards right are known as dextro. And they are also sometimes represented by plus sign here. And those amino acids which rotates the plane polarized light towards left are known as LIVO, and they are represented by negative sign. So almost all amino acids are optically active except glycine because they contain asymmetric carbon atom in their structure, and that makes it possible for it to rotate the plane polarized light. So if you place these molecules along the path of light, then it will rotate the light either towards right or towards left. Hence, it will exist in D form or L form. As I said earlier, D form stands for dextro-rotatory. When it rotates the plane polarized light towards right, and it is also represented by a positive sign. And libo-rotatory means when it rotates light towards in anti-clockwise direction, and it is represented by this one. So if you look at this structure, these are the structure, two isomers of alanine, and this is D form and this is L form. If you pass light, now you can see there. If you pass plane polarized light, this molecule will rotate light towards right. So this is dextro, D, or also can be written as plus alanine. So this is one type of alanine, D type, and we have another one here. Here it is LIVO type, libo-rotatory, because here you can see it rotates the light towards in anti-clockwise direction or in left, towards left. Hence, it is known as libo-rotatory. So these are the two different isomers of alanine. So similarly, all amino acids will have two forms, D form and L form. But one thing that we need to know is all naturally occurring amino acids will exist in L form. And that's why proteins are also made up of combination of large number of L amino acids. Now, next subtopic that we are going to discuss is formation of zwitterion. Now, when you talk about zwitterion, it's a dipolar. Formation of zwitterion, also known as dipole ion or internal salt. So what is zwitterion? It is a dipolar ion which contains positively charged amino group and negatively charged carboxylate ion. So you can see here in this structure, so this is amino acids. So you can see here we have R because we are taking it as general amino acids. R can be any alkyl group which is attached to alpha carbon. Now, what happens at a specific pH which is known as isoelectric point, this proton which is present on the side will move, migrate, and then form a coordinate bond with the lone pair of electron which is present on amine nitrogen atom of amine group, and results in the formation of new structure which contains positive charge amino sites and negative charge carboxylate ion. And this doubly charged ion is called zwitterion. So as you can see here, we have R, this is alkyl group, alpha carbon, amino group, and carboxylate ion. So zwitterion is a dipolar ion which contains positively charged amino group and negatively charged carboxylate ion. Carboxylate ion is formed. How is it formed? When carboxyl loses a proton and amino group is formed. And this is how this gets converted, amino acid gets converted into zwitterion. If I explain with the help of this structure here, now let me explain this way. What's happening? Let me draw from the beginning a good diagram R. So this is alkyl group, this is alpha carbon. Okay, I'll draw here amino site here, NH2 amino group. So we have R alkyl group here, we have hydrogen, and then we have C double bond O, OH. So we have both functional group, amino group as well as carboxyl group, amino group as well as carboxyl group. We have, this is our alpha carbon. Now, this alkyl group can vary. Different amino acids will have different alkyl group. The lowest one, that glycine, has H. Other than that, it will be always alkyl group. It can be methyl, it can be ethyl, it can be butyl, as I have already explained before. Now, what's happening here? So, as it moves here, this will be slightly positive, and now I'll just draw this bond. Here we have shared pair of electrons. Let's assume this is a shared pair of electrons between oxygen atom and hydrogen atom. Now we know that oxygen is more electronegative compared to hydrogen atom. Therefore, this shared pair of electrons will not remain in the center, but it will be pulled more towards oxygen. So as it gets pulled more towards oxygen, this proton is lost. This will come out not as hydrogen, but as proton. This will come out as proton. Hence, it results in the formation of new compound. I'll draw a very small compound, NH2, C, R, H. Now we have C double bond O, O minus. Why minus? Because both the shared pair of electron remains with oxygen atom when this bond breaks, as hydrogen is leaving this compound as proton. Now this proton will go and it will travel here. So we have lone pair of electrons here, and then this will form coordinate bond here. This will form coordinate bond. Hence, it will develop positive charge, and this will develop negative charge. So this is what we have. This is the structure of our zwitterion, and this will happen at a particular pH, which is known as isoelectric point. So as you can see in the structure here, same thing is explained, but here I have not explained, or I have not shown the electrons which is present between these two, oxygen atom and hydrogen atom. But you can see this hydrogen atom comes out as proton, and as it comes out, it forms coordinate bond. Therefore, it forms positively charged amino ion, and you have negative charged carboxylate ion. So this is zwitterion. Now, amphoteric character of amino acids. Now, as you can see here, in the structure, it contains two positively charged amino group and negative charged carboxylate ion. Therefore, it can behave as amphoteric substance. I know maybe in lower classes, maybe class 7, 8, 9, 10, you must have been studying about amphoteric substance. Amphoteric substances are those substances which can behave as acid when it reacts with base, and it will behave as base when it reacts with acid. Therefore, it can behave as acid as well as base depending on the type of reactant it is reacting with. So here, let's look at A, basic property that is in acidic solution. So just assume we have put this in acidic solution. So if you put in acidic solution, acid will donate proton. This proton comes from acid. Now as this proton goes there, it will combine with this one to form acid, carboxyl group now. So now the negative charge is cancelled, so we have amino group. So overall, this molecule is going to have positive charge. This molecule is going to have positive charge. So when it is put in acidic solution, when the pH of the solution is less than 7, so this is what happens. Let me explain this same concept here. So we already have NH3 plus. So this is alpha carbon. We have alkyl group, hydrogen, and then we have C double O, O minus. We know this is the structure of zwitterion. This is the structure of zwitterion. Now, since this is the structure of zwitterion, now what we are doing, we are putting it in acidic solution. So you know in acidic solution, acid will donate proton. So this proton will go and combine here, resulting in the formation of new structure, H3. This will remain as positive, Now this will be carbon, this will be alkyl group, and this is hydrogen, and now we have carboxyl group. Carboxylate ion gets converted into carboxyl group, OH. Now if you look at this structure overall, the charge of this structure is positive now because negative has already been cancelled by this positive charge. So overall this behaves as positively charged ions. Therefore, if you place this structure in an electrolytic solution, then this will always migrate towards cathode. It will always migrate towards cathode. So that's what is being explained with this one. Now let's go to next one. In acidic property in alkaline solution. Now, when you put base, then zwitterion should behave as acid. So how does it behave as acid? Because by donating a proton. So we know that in amino group, this proton which is present there, which is attached to this nitrogen atom due to formation of coordinate bond, will be taken away by the hydroxide ion which comes from base to form water. Now as it goes out, the positive charge on this one will be lost. Hence, overall, the charge of this molecule will be negative. So if you place this one in electrolytic solution, then it will always migrate towards anode because it is negatively charged ion. So again, I'll explain this one using the board here. Let me explain this part again in detail. So we have, I'm drawing the structure of zwitterion again. So we have carbon, alkyl group, we have hydrogen, and then we have carboxylate ion. So this is zwitterion. Now we are placing this in basic or alkaline solution. So alkyl, this OH minus comes from alkaline or from base. So as it comes here, so this base, what it will do is, it will take, so I'll write this structure like this, NS2, and then that proton is here. So this will come and take this proton to form water. So now what's left? NH2, C, R, H, now C double bond O, O minus. Now you can see it had both the charges, positive as well as negative. Now negative charges come, it has cancelled that positive charge. As a result, overall, this new structure will behave as negatively charged ion. Hence, if you put in electrolytic solution, if you put in a solution which has 2 electrodes, then this will migrate towards anode. This will migrate. So amino acids will migrate towards anode when you put in basic solution or alkaline solution, and it will migrate towards cathode when you put in acidic solution. So now let's look at isoelectric point of amino acids. As you can see the definition here, the pH of a solution of an amino acid at which it exists completely as zwitterion. Zwitterion, again, let's go back. This is zwitterion. It completely exists as zwitterion. Then that pH at which amino acids exist completely as zwitterion is called isoelectric point. The pH of the solution of an amino acid at which the acid exists completely as dipolar or zwitterion is called isoelectric point. Now some of the characteristics of isoelectric points are, number one, isoelectric point of an amino acid depends on the functional group. As I explained earlier, now this R can be anything, starting from H in glycine. As you go to alanine, it will be CS3. Then you go to leucine, C2H, it increases. Now, the isoelectric point of any amino acid will depend on this functional group, R here. And you can see, second point, neutral solution. The neutral solution of amino acids has isoelectric point in the range of 5.5 to 6.3. And now I want to inform you one thing here. So let's say this is the smallest functional group, that's R. R equals this. It can be CS3, it can be C2H5, C2H5, it can be C3H7. Now, as the size of alkyl group increases, the isoelectric point will keep on decreasing. That's why glycine, the isoelectric point of glycine is 6.1. As you go higher, pH will decrease and come towards 5. Now, peptide and peptide bonds. As I told you earlier, what is protein? Proteins is a polymer of amino acids. So which means so many amino acids, they combine together in the form of chain to form protein. So when they combine, they are held together by a special type of bond which is known as peptide bond. So peptides and peptide bonds. The compound obtained by condensation of two or more amino acids are called peptides. Now, when I say two or more amino acids, it can be same type of amino acids or it can be different type of amino acids. For example, it can be glycine, glycine, glycine combined together, or it can be glycine attached to or forming a bond with alanine, and alanine forming a bond with leucine. So it can be two or more amino acids. When I say two or more amino acids, it can be two or more similar type of amino acids or two or more different types of amino acids. So here, as you can see, classification of peptides, dipeptides. Di stands for two peptides. So when two amino acids combine together, it's known as dipeptides. Now, third one, tripeptides. Three. So when three amino acids combine together by peptide bond, it is known as tripeptides. The peptides formed by the condensation of three same or different amino acids. And polypeptides, many, poly stands for many. So when many amino acids are held together by peptide bond, the compound is known as polypeptide, and protein is nothing but a polypeptide of alpha amino acids. So polypeptides, the peptides obtained by condensation of large number of same or different amino acids are called polypeptides. So let's take some examples here. Now you can see here, we have taken glycine here, you can see, and then we have taken alanine. So these are two different amino acids. So this is going to be dipeptide, di because two. As we have already discussed, when peptide bond is formed, it can be formed between similar type of amino acids, or it can be formed between different type of amino acids. Now, peptide bond formation is a condensation reaction whereby a molecule of water is lost. So from here, carboxyl side OH will come out, and then from amine side H, they combine together to form water and resulting in the formation of bond directly from carbon to nitrogen, and that bond is called peptide bond. So this is an example of dipeptide, glycyl alanine. It's a dipeptide. So let's look at this one. So this two OH from one amino acid will combine with H of amine of another amino acids to form water. And this water goes out. And when this water goes out and bond is formed directly now from carbon with this nitrogen atom, resulting in the formation of peptide bond. And since we have two amino acids, dipeptide. This is an example of dipeptide. Similarly, we can have other examples, polypeptides. So now we are looking at proteins. Proteins are long polymers of amino acids which are linked together by peptide bonds. So we have seen how peptide bonds are formed. Now you can see here one amino acids and an amino acids. Now here we have taken general amino acids because we have not specified R. So it can be R, R dash, which means maybe this R and R dash may be same type or maybe different type. For example, if it is CH3 here, methyl group, and if it is methyl group, then both will be what? Alanine and alanine. But if it is H and H, it will be glycine, glycine, but they can be also different. So R may be equal to R dash or R may not be equal to R dash. Now it is a condensation reaction. So as we have seen earlier, OH minus from one amino acid will combine with H of amine side of another amino acids to form water and resulting in the formation of compound. And then when such bonds are formed between large number of amino acids, then proteins are formed. So proteins are polymers of large number of amino acids, alpha amino acids, which are held together by peptide bond. Now, let's look at biological functions of proteins. We all know, and especially those people who go to gym, tend to take lots of protein because proteins are known as bodybuilding foods. So, if I tell you some of the functions of amino acids or some of the functions of proteins, then first function, is proteins are primarily responsible for the structure and strength of the body. We need protein. We need to take sufficient amount of protein, maybe in the form of diet, especially essential amino acids, because it is known as bodybuilding foods. It will help us to keep ourselves strong, healthy, and keeps ourselves fit. Especially if you are a sports person, then you should take plenty of proteins, large quantity of proteins. Now, second one, some proteins act as enzymes, hormones, blood clotting factors, etc. These are the dynamic functions of proteins. Now, all these enzymes, let's say in our mouth we have salivary amylase, and all these enzymes are made up of proteins. So because of that, one of the main functions of protein is to make enzymes, to make hormones, to make blood clotting factor, etc. Now, denaturation of proteins. You know that in protein, different amino acids are held together by peptide bond, and these peptide bonds keeps them together. So sometimes we tend to destroy the structure of protein by maybe destroying secondary structure, or maybe by destroying tertiary structure of protein, and that leads to denaturation of protein. That process itself is called denaturation of protein. So if you look at the definition, is a process by which the native form of protein structure is disorganized. Again, by definition, is a process in which secondary and tertiary structure of protein is destroyed, but primary structure will remain as it is. Now, what happens because of this? This causes loss in biological activity of protein. For example, if it is an enzyme, it loses enzymatic activity. That's why enzymes are pH sensitive. Enzymes are temperature sensitive because they are all made up of proteins. Now, peptide bonds in the primary structures are not hydrolyzed, but helical structure of protein is lost. As I already mentioned you earlier, when you talk about denaturation protein, it is about the destroying the structure of secondary structure and tertiary structure of proteins, amino acids, but it's not, the primary structure will remain as it is. So one of the simplest example of coagulation of protein is the coagulation of egg white on boiling of egg protein is an example of irreversible protein denaturation. So you know that when you are boiling an egg, when you are boiling an egg, you take out egg, and then if you break that egg and then just look at it, the white part, albumin part of the egg will be almost like semi-solid. But as you boil, it gets converted into solid form. And that process is called denaturation of protein. There are so many other examples of denaturation of proteins. For example, extracting cheese from milk is another example of denaturation of proteins. There are so many other examples. So let's look at one video here. So as you have seen this video here, where the white part of egg is denatured, and there are so many factors which leads to denaturation of protein. One, it could be temperature. Another one, it could be pH. Another one, it could be other impurities that also leads to denaturation of protein. Whenever protein gets denatured, its biological activity gets lost. Now, finally, we have come to the end of our lesson. So let me revisit again and then focus on those important points that we have learned through this lesson. First, what are amino acids? As you have discussed already, this is a special type of acids which contains two functional groups. I'll use this board to explain you this. Amino acids are a special type of acids which contains amino group on one side as functional group, carboxyl group on other side as functional group, and we have R, this is alkyl, and then we have hydrogen atom. So this carbon which is attached to this functional group, carboxyl group, is known as alpha carbon. And all amino acids will have same structure, except this R will change. We change in different types of amino acids. For example, if it is glycine, this R is going to will be H, where this is the simplest form of amino acids. If it is alanine, then this R will be CH3. So only this R will change. All other structure will remain same for all 20 different types of amino acids. And then as we have seen, this can behave as acid as well as base, and especially at a particular pH, it will get converted into zwitterion, whereby this H hydrogen atom from here migrates towards this and forms a coordinate bond, therefore leading to a formation of dipolar ion, negative charge carboxylate ion and positive charge ammonium ion this side. And this is our zwitterion. This is very important in chemistry. Now, when you place this zwitterion in acidic medium, it behaves differently, and when you place this one in basic medium, it will behave differently. Let's look at this. Now, let's assume that we are placing this in acidic medium. So acid donates proton. So when you add acid, or when you place this zwitterion in acidic solution, then this proton will combine with carboxylate ion here, resulting in the formation of a new structure where you have, so negative charge is completely cancelled here, but you still have this positive charge, so it will behave as positively charged ion, and then this will always migrate towards cathode because it is positively charged ion, cathode. So in this reaction, if you look at this is behaving as base because it is reacting with acid. Why base? Because it is accepting proton, hence it is a base. Now, if you put in alkaline solution, then alkaline solution will donate hydroxide ion. Now, when this hydroxide ion goes out, it will combine with one of this proton which is there to form water. Now, the new structure that will be formed will be this one, NS2, then we have carbon, alkyl group, hydrogen, then we have C carboxylate ion. As you can see here, now positive charge on amine side is lost. Now, overall, the charge of this compound is negatively charged. And if you put, if you place in a solution which has two electrodes, cathode and anode, then this will migrate towards anode. And here it is behaving as acid because it is reacting with base. So therefore, we have already discussed that amino acids can behave as acid as well as base. Hence, it is an amphoteric substance. And other important points, amino acids are building blocks of proteins. When so many amino acids combine together by the formation of peptide bond, which is a condensation reaction, it leads to the formation of proteins. And we know proteins are very important in our day-to-day life. These are the bodybuilding foods. And also we have seen that there are two types of proteins, one essential amino acids and one is non-essential amino acids. As we have already discussed, essential amino acids, those amino acids which cannot be synthesized by our body, it has to be taken from external source, maybe in the form of diet. It can be taken from plant source or it can be taken from animal source. So with all this, we come to the end of our lesson today. So before we end our lesson, I want you to go through these questions. We have 5 questions here. Let's read these questions one by one. First question. Amino acids behave as zwitterion in neutral solution. Towards which electrode will amino acids migrate in basic solution? Why? Now, you have to explain. So in neutral solution, it will behave as neutral ion. Now, towards which electrode will the amino acid migrate in basic solution, and why? You have to explain this part. Second, define denaturation of protein. Third question, what is the effect of denaturation on the structure of proteins? Fourth, what is zwitterion of amino acids? And the last question is, explain isoelectric point of amino acids. Please explore, go through different sources, maybe you go through textbook, get help from your chemistry teacher and try to answer these questions. I hope you enjoyed today's lesson. See you in next lesson. Thank you and have a great day.